Okay, so I'm recording now. Welcome to the last class of this week. We're going to go through two topics today. We're going to finish the exponential topic and do topic 1.5. We're a little bit behind. Probably should have been at 1.6 today, but that's all right. Okay, so somebody in a private message said something about rule 2 on page 29. So let me have a look. Oh, okay, cool. So I can do that right now. I think yesterday where I had to move to my bedroom because somebody was working on something in my apartment. I might have missed this page. Thank you for reminding me. So let's look at this rule. This is actually a very important rule, and I apologize if I skipped over it. So again, for the new people or the people who haven't been to class yet, you're kind of starting, page 30. We're right in the middle of this unit, so you're going to have to catch up a little bit this weekend. So for anybody today who is completely lost, unfortunately, you're going to have to watch a few videos. I don't have time to go back, right? Pretty busy this intersession. So yesterday we were looking at rules of exponents, and we talked about the multiplication rule. We actually did rules number 3 and 4. And for some reason, I skipped rule 2, which is very important. And I do appreciate you telling me that I forgot that. So the division rule for exponents are when you divide two exponents or two numbers with exponents that have the same base. Just a reminder, the base is kind of like your regular number. It's not subscript. It's kind of like, the base, the lower number. So I could say like 2 to the power of 6. The base is the 2. The 6 is the exponent. And in, when if you're typing in Word or something, you would call the 6 a superscript. In math or science, we just call it an exponent. Okay, so the rule is if I divide two numbers that have the same base, that's very important. The numbers must have the same base, like exactly the same. It could be a variable like X, Y, Z, A, B, C, or it could be a numerical base like 2, 3, 4, 5, 6. It has to be the same. And if you divide those and the bases are the same, you can just subtract the exponents. Now, the way that this works is based on what we were doing in topic 2, where we were canceling units. Well, if you divide exponents, you just cancel those bases. So the example in the notes here, x5 divided by x squared. Well, we have 5 x's, and we're going to divide or remove 2 of them, which leaves us with 3. So let's look at some practice problems here. Some of these are pretty crazy looking, but they're pretty straightforward once you know the method. Before I get into the example, there's 6 chat messages. So let me just check that. I have a feeling it's more about WhatsApp than me. Whoa, that's a big link. Somebody, I think Hoda just sent a link to the WhatsApp. So that's great. I'm in there too, but I haven't been on WhatsApp in a little bit. Okay, so these examples, let me show you the 6 of these, and then I'll get you guys to practice, and we will move on. Number 1, nice and easy. Let me zoom in, I guess. There we go. I assume you guys can see my screen. Nobody has said anything. X to the power of 8 divided, or sometimes you'll hear me say over. I just mean divided by x to the power of 3. So I have 8 x's on top, 3 on bottom. That means I will remove 3 of these from the top. 8 minus 3 is 5. So again, like think about this. I have 8 x's. I'm going to take away 3 of them. Now I have 5. Question number 2, equally as simple. The only difference here is the base is not a variable, it's a number. So I have 3 to the power of 7. So like on the top, I have 3 times 3 times 3, 7 times. And then on the bottom, I have 3 times 3, or 3 squared. So I'm going to remove 2 of those, right? So 7 minus 2. The answer is 3 to the 5. Now, something I mentioned last day, and again, the new students, you might not know, have heard this. When you're dealing with numbers, I want you to express the number. This actually wouldn't be simplified, but I want you to express it as a number, not as an exponent. If you said 3 to the power of 5 on like a test or an assignment or something, you might lose half of a mark. Well, maybe not. I'm seeing how generous I feel. But what I expect is for you to solve that. And something I mentioned in the last few classes is you guys are going to need very soon to purchase a calculator. I recommend the Casio brand. Actually, I'll show myself on video again. This type of calculator, you can get them at Carrefour and Lulu, maybe Monoprix, but I know I've seen them at Carrefour recently. Landmark and City Center have them. I mean, wherever you live, if there's a Carrefour, Lulu, or maybe a Monoprix, I haven't checked Monoprix, but get a calculator like this. It is, of course, at the bookstore, but getting on campus can be a little hard these days. But yeah, bookstore as well. 100-ish reals maybe, but it's a good investment. And if you don't need it after this course, you could sell it to a college student because everybody needs this. So I don't expect you guys to be able to do or to want to do 3 to the power of 5 in your head. So I would put that into my calculator and get 2, 4 to 3. All right, let's move into some harder ones and then I'll get you guys to practice. Number 3 is a good example of how the bases need to be identical. I have X and Y in this equation, and we cannot combine them. They're different numbers. X and Y we call variables. They could stand for completely different things. So I can't combine them. I can, however, combine the two X's and the two Y's. So for number 3, I have a 7, or X to the power of 7 and X to the power of nothing, which means a 1 is there. 7 minus 1 is 6. For the Y's, I have 9 on the top, 6 on the bottom, so 3. 9 minus 6 is 3, pretty easy. All right, 4, 5, and 6. Number 4. The difference or the unique thing about number 4 is that there are non-exponent numbers included. We call these numbers, and I mentioned this yesterday, coefficients. See if I can spell that. Okay, coefficients. Coefficients are just numbers in front of a variable. So 24x is an example. And with the coefficients, you just divide them normally. 24 divided by -6 is a -4. Review integers, again, for the new students, we did this earlier. You can always use your calculators as well. Okay, what about the x's? 15 minus 2 is 13, and the y's, 11 minus 3 is 8. I mean, this is pretty straightforward. I don't think I need to do all 5 of these. It's more of the same thing over and over and over. So why don't you guys just give this a little practice? Maybe if you guys, I like E. Maybe if you guys could do C, D, E, and F for me. Give this a try. I'll be back in 3 minutes. This shouldn't take you very long. I really like E, by the way. I think E might give me some interesting answers from you all. But try C, D, E, and F, and we'll be back in 2 or 3 minutes. Okay, and if you have any questions, you can turn your mic on or type it in the chat. Good luck. Okay, I'm just keep going. You take it like it's only been 2 minutes. Take another minute or so. You know, finish what you can. I got a couple things to talk about in a minute, or with the new students here about this book. You're going to see like hundreds of problems. We will not do them all, but I'll talk about that in a minute. But there's 2 things I want to mention. I have a private message that says, what if we have a bigger exponent in the denominator? That's a great question. There's 2 ways to, oh, I'm getting a lot of questions now. Hold up. There's 2 ways to answer that. I'm going to say your name, even though you sent me a private message, Amar. That because it's such a good question, I will explain that in a minute, okay? I think it'd be better if I could write this down. So I'll come back to your question in a minute. For the people who can't see that question, it is, what if the denominator has a bigger exponent? And there are 2 ways. Mateb is sharing some answers, and for E, you did something interesting, which I'll talk about in a minute, but I will tell you it's not 0. I have another private message from a student, which I will keep private, but I was in the same situation as you the other day. I had a student this morning in your situation. Basically, guys, if you're not feeling well, it could be from Ramadan, from fasting, no sleep, and in this case, the second dose of vaccination. That happened to me the other day. My brain was toast. So if you guys, and for this student, if you're not feeling well because of you're coming off the second dose of a vaccination, you can go. I've marked you as attended. You can watch the recording later this weekend. And I really hope you feel better, because 2 days ago, that was me. It was a really rough 24 hours. So feel better. So Dustin, Abdul Rahman, Fatima, Hoda, thank you very much. Nasser, everybody, good answers for E. Let's check it out. Let's look at these answers now. Did I pause my recording? No, I didn't. Let's look at the answers. I really want to focus on E, and I want to answer the question that somebody wrote me. I think it was Amar. What if the denominator has a bigger number? We're going to actually look at that today, but I will talk about it now. So let's look at our answers. So C, very simple. It's 19 minus 11 A's. So 19 minus 11 is what? 8. And B, 3 minus 2. So you could just say B to the power of 1, or just B. You don't need to put to the power of 1. D, 13 minus 11 would leave me with 2 X's. Y would leave me with 12. And Z, or Z, would be 5. Okay, I'm going to do F, and I'll come back to E. So for F, the first thing you do is divide the 24 and the 8. So 24 divided by 8 is what? 4? 3? 3. 3, my brain. 24 divided by 8 is 3. Now look at all these numbers. 10 minus 10 is 0. Like there's nothing left. So 10 minus 10, 14 minus 14. What happens is all of these cancel and just leave me with a 1. So the answer is 3 times 1, or 3. And this is actually what's happening with E. I had a couple students say that it was 0. But what happens is when these guys cancel, you're just left with 1. There's a rule in exponents, which I'll talk about a little later, but any exponent to the power of 0 is 1. You can try that on your calculator if you don't believe me. You should believe me, but well, maybe not always, but put any number you want in your calculator, like literally any number, raise it to the power of 0, it will equal 1. It's not 0. And that's a really good, this was a good question to practice with. So in the chat, Aman asked, what if the denominator had a bigger number? I'm actually going to do that in the next rule. So I said I would answer it now, but I'm going to save that actually for the next rule. That's such a good question. Before I move on, let's check the chat, see what's going on in there. Okay, I have a student who your name is they're writing me a private message. Your name is iPhone. Can you change your name to like your actual name? This will help me with my attendance. And do not worry about being late. It looks like you're going to the airport. So can you just tell me your name before you go to the airport?
Hussein Ayub.
Hassan?
No, Hussein Ayub.
Oh, yes. Okay. Yes. Cool. Perfect. All right. Good luck. Fly safe. All right. So yes, private message from Mona. The answer to E is 1. I just mentioned that what happens is when, if I took P to the power of 10 and P to the power of 10, when you subtract those exponents, you get a 0. P to the power of 0 is 1. Any exponent to the power of 0 is 1. So the answer to E is 1. The answer to F is 3 times 1, which is 3. We'll talk a little bit more about that rule today too. There's going to be a lot going on today. Not the best way to spend a Thursday, but anyways. Rule number 3 and 4, guys, we did yesterday, and I do apologize for that, for missing rule number 2. Rules number 3 and 4, if you want to see these rules, check out the Wednesday recording, which is on YouTube. So we've done this. I'm going to skip down. There's a lot of practice here for my new students. The practice is meant for you, not for me. I've done my practice in math, so it's not for me. Meaning I'm going to be skipping a lot of practice questions. You can think of this like a worksheet, and the answers are on D2L. All right, so back to where I started, rule number 5. Did I even do, I think I did rule 5 yesterday, kind of, but we'll review rule 5, and we'll look then at this 0 exponent rule, which I just kind of hinted at. Okay, the rule 5 is really easy. It's very much like what we did yesterday. So rule 5 is called the quotient to a power rule. Sounds really complicated. It's really not. If I have brackets and I have inside those brackets a fraction and I raise that to an exponent, the exponent goes on to everything in those brackets. That sounds really complicated coming out of my mouth, but I'll show you. I'll write down some examples. The idea is this is just like rule 3 and 4, and this is like what we did in the first class. It's like the distributive property. Because that M is outside the brackets, that M meaning any integer or any exponent, gets distributed or shared with everything inside those brackets. It doesn't matter if it's a fraction or a number, it gets shared inside. So there's a really good example here in yellow, in the yellow box here. I have a fraction, and then I have to the power of 3. Well, what that means is this 3 gets distributed to everything in that question. So I get 3 to the power of 3, x to the 4 to the power of 3, 4 to the power of 3, and b squared to the power of 3. And for the people who missed yesterday's class, because the 3 is here outside of the brackets with the 4, I multiply those numbers. Again, I did this yesterday, so if you missed how to do that, please review my materials from yesterday. So let's look at some examples here. I'm going to do the same thing. We'll look at examples. You guys practice. We'll move on. Repeat. Examples, one is a little bit too easy. It's just a warm up, but wink, wink, right? Examples 2 and especially example 3 are pretty challenging. So let's look at example number 1. I have in brackets x over 5, and I'm squaring everything in those brackets. Remember, when I say square, I mean to the power of 2. So what this means is I'm going to get, let me write it here. hold on. I'm going to write this as x squared over 5 squared. Now, I don't really want you to write 5 squared. I would much prefer that you solved it, calculated it, so it would be x squared over 25. That was a pretty easy one, a good warm up. 2 is kind of our middle of the road difficulty. There's some extra things going on with number 2. So the idea with number 2 is, I'm going to break this down a little bit more than the book. I'm going to square the 3. I'm going to square the x cubed, and you'll notice I put that in brackets. I'm going to square the 5, and I'm going to square the y to the power of 4. So 3 squared is, of course, 9. 5 squared is, of course, 25. And here, this is for students, well, it's for all students, but if you missed yesterday, this is I guess not a reminder, but new information. These get multiplied. So 3 times 2 is 6, 4 times 2 is 8, and that's where we get that answer on the bottom. A lot of these rules are repetitive, right? We're kind of doing the same thing over and over and over. We're just kind of looking at every different type of possible question you guys could get with an exponent. All right, Nasser, you have your hand raised. What's up? You have a question?
Mr. Mark, can we put all of the numbers like in one bracket?
Do you mean for like your final answer?
No, not in the final answer. Like 5 and y. Like, can I put it in one bracket and multiply the exponent like by all of them?
Yeah, I know what you mean. Yes,
Yeah.
yes, you can, but be careful. I like what you're basically saying is what I'm circling in blue here.
Yeah.
Be careful, because when you write 5y4 squared, don't forget that that 2 also goes with the 5. So I need to, I need to square the 5 and then do the work with the y.
Okay.
Yeah, but you can, yeah, you can do that. Yeah, you're welcome. The cool thing about math, I think, is there is more than one way to do a lot of these things. You know, I'm such a fan of breaking things down. I use a lot of brackets. If you ever saw me put something in my calculator, I use like so many brackets to simplify, well, to make sure it works, I guess. But yeah, if your method works, if you write it a little differently than me, that's fine. You'll find a lot of math instructors have different methods. So yeah, good question. Okay, number 3. You see this little annoying light bulb in the bottom corner here telling you something. This is something we talked about yesterday. This is challenging because it's like a hidden number. Look at question 3 and look at that negative in front. That negative is basically a math person trying to say that there is technically a -1 in front of that number. I do mine a little bit differently than this little light bulb here. So let me kind of show you how I would approach this. So I have, you know, bracket negative m5n cubed. Actually, I'm going to do this way differently than this light bulb. I'll show you what I mean. Over 2m squared n. And all of that's cubed. You know, what I would probably do with this is why not simplify this? You know, before, like, think about this light. I think this light bulb is wrong, guys. So remember BEDMAS? For the new students, the order of operations, we did this in class 2. Do what's inside the brackets first, right? So why wouldn't I simplify this first and make my life easier? So negative, now m5 and m squared, that leaves me with m cubed on top, you know, 5 minus 2. N cubed divided by n would just be n squared, and it's still over a 2. Okay, that makes life so much easier. But now all of this, everything in this bracket gets cubed. The only thing I could see here that you guys would probably mess up on a test, and I don't mean everybody, but this is something like I'd probably miss when I was a student, is this negative. This negative means that really there's a -1 in front of this. So now I can kind of simplify this question like this. Doesn't look like I'm simplifying it, does it? And I'm going to cube everything. So I'm cubing, and when I say cubing, I'm raising it to the power of 3, everything. So -1 to the power of 3 is still a -1. M cubed to the power of 3 is m to the 9. N squared to the power of 3, n to the 6, and 2 cubed to the power of 3 is an 8. And that's where we get our answer above. You can see I ran out of room. I guess I could do this, couldn't I? Here, let me write that out for you. I made more room for myself. I'll just erase my writing here. Okay, so if I simplify this guy that I have on the top, I would still get my negative. -1 cubed is still a -1. And then I would get m to the 9, n to the 6 over 8. Oops. Yeah, there you go. That's an 8 on the bottom. Kind of looks like a snail. I'll fix it. Oop, there you go. Whew. Okay, so practice time. I'm going to get you guys to do a little bit of practice. Why don't you try the first 3? B being a challenging one. C and B, I would focus on, if you were studying wink, wink, wink for a test that would come up in a few weeks. B and C would be good practice problems. A is just a nice warm up. So I'm going to mute myself as usual. You guys try A, B, and C, and then we'll basically finish off exponents and start the next section. I got a little bit of, I got a lot of math to teach today. So take 3 minutes. I will be back at 2:50. You can share your answers in the chat if you want. Good luck. All right, I'm back. The chat has been quiet, but you know, this is pretty hard to put in to a chat message, and you guys don't have to waste your time if you don't want to type all this out. Like you kind of got to, with distance learning, where I can't come and look at your desk, look at your workings. We're on the honor system, so I'd love for you guys to try this. If you don't have your notes printed, just get a piece of paper, anything. And try this out, and we'll go by the honor system, or you can go by the honor system and see if you get it right. Fatima in the chat, though, is sharing with me answers to B and C. So let's check it out. Your B looks good. I can tell right away because I like that you didn't say it was negative, and I'll talk about that negative in a bit. The negative sign is going to give students some problems. I can see it now. It's something I would mess up years ago, or even now. I make mistakes all the time. So a good little warm up here. 2 to the power of 4 over y to the power of 4, easy, right? You distribute or move the 4 to the numerator, top, denominator, bottom. The only thing I'd want you to do is actually solve 2 to the power of 4. So for a perfect answer and a happy instructor, 16 over y to the power of 4 would make me real happy. I'll tell you one thing, I am happy. I was talking to the other instructors today. They're getting like 6 to 10 students per class. I have 24 right now, with 1 student gone because of the vaccine, and another student at the airport. So I'm counting that as 26 students. That's pretty good. Keep the attendance up. This will really help you. Let's skip B for now. Let's do C. C is a little easier. I think it's easier. So I want to put that exponent with everything. So 3 to the power of 3, x to the power of 5 to the power of 3, 2 to the power of 3, and then my y. All right, so I'm going to get 9x to the 15, 8y to the 30, and there you go. A common mistake here is you guys might add the exponents. If you added the exponents, remember that's different. We don't add exponents when they're outside brackets. All right, let me check the chat before I do B.
Mr. 27, not 9.
Yep, you're correct. I literally a minute ago said I make mistakes, and there we go. Yeah, of course well, I shouldn't say of course, but yes, it's 27. 3 cubed is not 3 squared. My brain just thought it was. I don't know why. So 3 times 3 times 3 is 27. I very much appreciate the correction. Anytime I make a mistake, let me know. Keep me on my toes. Okay, so B. B has that secret -1 there. So I'm going to separate that. -1 squared.
It becomes a positive.
And it becomes
positive. Yeah.
Yeah, exactly. That's perfect. Yeah. And you really want to be careful, because if it was like a 3 or a 4, you got to watch out. And you can do this on your calculator, but yeah, this becomes a positive. And then I'm going to take 8 squared, x cubed squared, and then 3 squared. So this, as I don't know who that was, but I didn't see your name, but this becomes a positive. So it's positive 16 x to the 6 over 9. I got 9 right that time. And I think that's it. I don't think I can simplify 16 over 9. Nah.
No, it's wrong.
Is it wrong?
Is it?
I don't think so.
Wouldn't that
Wait,
be 64?
It's 64. Yeah.
Yeah.
On
Yeah.
9 and the x.
You guys, if I could give you bonus marks, I would. Maybe, guys, I'm trying that. I'm trying to keep you guys on your toes. Yeah, 8 squared, 8 times 8, 64. And guys, don't think that this is a plus. I'm just emphasizing that this is positive. You don't really in math mention that a number is positive. You just kind of leave it there. So if anybody's wondering, where did that -1 squared go? that just becomes a 1, which we don't include ones. Perfect. Good job, guys. I'll wake up in a minute. It's been a long day. It's been a long week. It's been a long year. So let's keep going. And you don't understand how much I appreciate you guys keeping me corrected. And Jahan said you did the same mistake. Yeah, it happens. You know, my brain saw 8 squared and I said, oh, 8 times 2. But this is why I shouldn't be using my head. I should be using my calculator. Okay, we're almost done exponents. We're getting there. And this is going way, way back, maybe 30 minutes ago or 25 minutes ago to Aman's question. If you're still here, you mentioned, what do you do if the denominator is bigger than the numerator? And that is in rule 7. So guys, I still need some more of your time. Technically, we go till 3:40. Hopefully, we can get you guys out of here before that. But I want to finish 2 more rules, do some practice, and then I want to introduce the next topic. Okay. This weekend, if you're wondering what to do, because I know you're all bored and you need something to do this weekend, I would definitely review the first couple topics, especially this exponent topic. But anyways, let's keep going. 2 more rules. The first, rule 6 is easy rule. Any number to the power of 0, and I mentioned this earlier, literally any number to the power of 0 is 1. 1,000,000 to the power of 0, 1. Decimal 0.00622 to the power of 0, 1. That's it. We saw this earlier when we were doing that question with the P's and the Q's. I had P10 Q10 over P10 Q10. And the idea was, you know, P10 minus 10 would be P0 and Q10 minus 10 would be Q0. So some of you, I remember Mona mentioned or asked, you know, so the answer is 1. Why is it 1? Well, both of these are 1. Anything to the power of 0 is 1. The last rule, and you'll notice that rule went really quick because, again, if you see something to the power of 0, it's a 1. You can do that on your calculators if you don't believe me. Okay, the last rule, probably the most challenging of the rules, the negative exponent rule. And this goes back to what Aman said. We're going to see this happen when the denominators are bigger. You're going to get a negative number. What does a negative exponent mean? A negative exponent creates, basically in science, in math as well, we would call this an inverse. It flips the fraction, we'll say, to become a positive exponent. Oh, that sounds really weird, but that's the rule. When you have a negative exponent, you can turn it positive when you flip the fraction. And I know it doesn't say that on the slide. It mentions to rewrite it. But the negative exponent rule means if you flip the fraction, it can become positive. So, okay, what do I mean? Let's say I had 2 to the negative 3. I could write that as 1 over 2 to the positive 3. Well, let's make it even more crazy. What if I had 1 over 2 to the negative 3? Well, I could flip this and just say that it's 2 to the positive 3 over 1. Negative exponents can be made positive by moving them in the fraction, moving them up or down. I wouldn't worry too much about this because you're going to see how we're going to work with this in a minute. Like you don't have to make them positive. You can leave them as negative. So, and again, you can see an example here in the orange or yellow. Let's look at some examples. I'll let you guys or ask you guys to practice, and then that's it. Well, no, that's not it. That's it for this section. The first set of examples are very straightforward. I'm going to go a little quick through these because remember, everything to the power of 0 is a 1. So A, 9 to the power of 0, 1. B, watch out for that negative. That negative is not in brackets. That negative is not to the power of 0. So you can see here, look at B, where I'm writing in the blue, you can read,
-1.
yep, you scared me. Yeah, you can write that as -1 to the power times 9 to the power of 0. There are no brackets here. And because there's no brackets, that negative is not related to the exponent. They're separate. So I get -1 to the times 1. The answer is -1. For something like B, you can do that in your calculator. All right, C. This is a good one. Look at this. Everything is in brackets. And on the outside of those brackets is a 0. So what that means is everything inside that gets put to the power of 0. The whole thing turns into a 1. Okay, so my answer is 1. D. Well, let me rewrite D just to give it a bit of space here. It's -9 x, y, z, or z to the power of 0. But that that 0 is only touching the z. So the z becomes 1, or the z. I think Canadians say z. I don't. I'm a bad Canadian. I'm a Z man. But the z or z is the only one affected. So I get -9xy. The z just goes away. You could write 1. I'll tell you this right now. I will never, ever, ever mark you wrong if you put a 1 in. You just don't need it. But you're never wrong if you put a 1 there. Okay, what about E? E is I personally, I would never give you something like a question like E. E is just written to challenge you. No normal human would write a question like E, but sometimes math teachers are not normal humans. You really want to look what is the 0 touching? Whatever the 0 is touching turns into a 1. So the negative stays. Let me kind of erase this. I'm writing a bit too. Maybe I'll zoom in. Oops. Okay, if I zoom in, this might make my life a little easier. Only what the 0 touches turns into a 1. So I'm still left with a negative. I'm still left with a x, and I'm still left with a 9 or a 3 squared. Some of you, when you do E, you might answer E as -x times 9. That's completely correct. It's just in math, we like to put the numbers in the front. They're called coefficients. I don't care if you put the 9 first or after, but it's a math preference to put the number first. All right, F. 3 over -4 to the power of 0. The negative stays, but the 4 goes. So it ends up being 3 over -1, which is fine. I would totally take that as an answer, but you can simplify that to -3. Whew. Okay. Negative exponents. Let's look at some of these. It says write all of the answers with positive exponents. So A is a nice warm up, 2 to the -4. Well, I could flip that, turn it into a fraction and flip it. It becomes 1 over 2 to the power of 4. And then I would like to simplify that and write it as 1 over 16. B, nice and easy, x to the -3. I could flip it and write it as 1 over x to the -3. C, same thing. Keep in mind with C that the 2 is not involved with the -4, so the 2 stays. The x goes to the bottom and becomes positive. This is kind of, I'm explaining this over and over, but I think if you guys practice this, it'll hopefully make more sense. I like number D. Look at D, or letter D. D is a good one. D, I have 3 over 4 to the power of -2. And I told you to make an exponent positive, you flip the fraction. So I flip this fraction here. So instead of 3 over 4, it becomes 4 over 3. And the exponent turns positive. So you would get 16 and 9. 4 squared, 16, 3 squared, 9. E and F are again pretty straightforward. I will do them, but G and H are the complicated ones. So E, -3 to the power of -3. Well, I can make that positive by, flipping my fraction, and I would just solve -3 cubed. Pretty easy. Both of these are answers for that. F, this is a good one. Because the exponent's on the bottom, I can move it up to the top. I get 3 squared, which is 9. How are you guys doing before I go to the crazy ones, G and H? Everybody okay?
Yes.
Yes, okay, good. Okay, G and H are a little bit more intense. So let me show you those. I might write these out myself. Let me check the chat before I move on. Oh, Faiz, you might be Faisal. There's a link posted above for the WhatsApp group. Hoda posted it, but I think she's gone. I can share it again. I think that's from another student. Oops, sorry, I wrote that to somebody privately. It's Mona, ignore that message. This is a link to the WhatsApp group that Hoda sent. I can't confirm that it works, but check that out. All right, sorry. G, 3 x minus 7, 5 x minus 5. Now, the first thing you do with this question is follow the rules of exponents, meaning first thing I'm going to do is subtract these exponents because they are divided. Now, -7 subtract -5. Be careful with your integers. You can use your calculator if you don't trust yourself. Maybe I should be using my calculator as well. This becomes 3x to the -2. -7 minus a -5 is a -2. What it becomes is -7 plus 5. Okay, now to simplify this, because this is negative, I can put it on the bottom like that. Actually, G wasn't bad. I think H is a little crazy. So I'll let you absorb that for a minute. I am going to erase my writing so I have room for H. Okay. Take a picture, take a mental shot. Remember, this is on YouTube. So if I'm going too fast or you need to see something again, you can check the YouTube and skip ahead. But I'm deleting that so we can do H. All right, H. So H is 2 to the -1, x to the 6, y to the -7, z to the -1, x to the -5, and y to the -2. For Aman, who asked the question earlier, what do you do if the denominator is bigger? I hope you're starting to see the solution of that. If your denominator is a bigger number, it will give you a negative exponent, which you can turn positive. Okay, so first thing I'm going to do with this question is simplify, well, basically everything. So let's write it like this. 2 to the -1. Now I'm going to solve my x. The x is going to be 6 minus a -5. My y is going to be, oops, sorry. I just want to make sure I'm writing. Okay, yeah.
-7 minus -2.
Yeah, thank you. I just want to make sure I wrote it down correctly. Thank you for that. So -7 minus a -2. Again, guys, you can use your calculators for this. And then z or z is just z minus 1. Okay, so this becomes 1/2. 6 minus a -5 is x to the 11. You can do that on your calculator. -7 minus a -2 will give me y to the -5. And then I have z to the -1. Now, anything negative, I'm just going to move to the bottom. So I get x11 over 2y5z1. And you don't need the 1 there. Guys, that's about as hard as they'll ever get. The way that these practice problems work is that, they start too easy, really. Like, A and B you probably wouldn't see. C and D and E are good questions. G, I think, is another good question. And then H is literally as hard as they would get. We're getting close to the end. I know this is a lot to absorb for today. If you're feeling overwhelmed, you're tired, whatever, take a break. You can watch this on YouTube this weekend if you need a break. I'm just trying to keep up with the other classes. The other classes are going very fast and it's kind of scaring me. So there's just a couple more little things I want to do. First, I want you guys to practice. Now, this annoying little light bulb here is giving some extra tips. I'll let you guys read those. This is just some tips, which I've already actually talked about. I am your light bulb. You don't need this guy. But if you don't listen to me or you're zoning me out, you can read this little light bulb here. You guys might be too young to remember Clippy, the little paper clip from Microsoft Word, but that's what that light bulb is. I have an unreasonable hatred for that light bulb. All right, let's give you guys some practice. Now, I want to make this good. I want to make it fair. I want you guys to try. Let's give you guys a challenge for practice. I mean, it's Thursday. Let's see what you can do. Why don't you try just 2 of them and wink, wink. You might see something like K and M on your assignment next week. For the new students, there's about 4 assignments and 2 tests. You're going to have your first assignment next week. Don't worry about the assignment. It's not like you have an hour. You can take a few days to do the assignment. It's only 7 questions. We're working on it right now. But wink, wink, something like K and M you might see again. So why don't you try these 2? I'll be back in 3 minutes, and then we are getting very close to the end. Okay, I'll be back in 3 minutes. Any questions, let me know in the chat. All right, folks. Now I specifically picked or asked you guys to do difficult problems. But by the way, there was just a really good question in the WhatsApp group, and I decided to respond on all of your behalfs about the assignments and the tests. I highly recommend any new students check out the first YouTube video. Okay, in the first YouTube video, I go over evaluation, assignments, tests, all sorts of things. Okay. So I picked for you guys some hard ones. Let me check the chat before I move on. Okay, Jahan mentions, Jahan says, I'm confused. I'm a little bit lost. I'll wait for the answer. And then Fatima and Isra are giving me answers. If you're confused, it might be because the two I asked you to do are not easy. So you might want to start this weekend or tonight trying some of the, I guess, easier ones or more straightforward ones, like F, for example. F 4/5. I know I didn't ask you to do F. I'm just going to show you. I want to make sure I'm recording. Yep. Sorry. So let me get rid of that. 4/5 stays normal, but because these x's are divided, I'm going to subtract the exponents. So what I end up getting is 4/5, and then I get x, and it's -8 minus a -5. Again, I've said this a few times. You can do this on your calculator. It ends up being -8 plus 5 or -3. Now, I want that fraction or exponent to be positive. So I could write this as, sorry, I'm out of room there, 4/5 and x to the +3. When I move the exponent to the other side of the fraction, like when it crosses the fraction line, it turns positive. And that's kind of a good way to think about this. It doesn't matter where the number is. So like if I had x to the -3, if I move this across a fraction line, it turns positive. And it could be for a fraction on the bottom of the exponent. When I move it across that line, it becomes positive. So anytime you cross an exponential number across a fraction line, it changes its sign. It becomes positive or negative. So let's look at K. 4, there's nothing to do with the 4, but I'm going to say A is -4 minus a -1. Oh, hold up. Hold up.
Mr. Mark,
Yes.
can I say the answer?
Yeah, you can say the answer.
4A7B over A3.
If it's
Nope.
if it's over
Nope.
A3, you should get rid of those A's or do something with those A's.
4A
Oh,
over 4
it's
B.
you subtract them. You subtract them.
Yes.
Like if they. Oh, okay.
Yeah. So some of you guys, are you saying the answer is 4A, 4B, like this?
Yes.
All right, let's see. Let's check it out. I don't know. I haven't done it. So, okay, I want you to look at all of these A's. So I get A -4. I'm going to add to that a 7 because they're on the top. And then I'm going to subtract from that a -1. I picked a hard one for you guys. Then the B, it's going to be -1 minus a -2. So if you're wondering, again, where this comes from, let me change my color. Where this comes from, I add the 4 and the 7 and I subtract the -1. So my answer becomes 4A. Now, -4 plus 7 is a +3. +3 minus a -1 is +4. And then B, -1 minus a -2 is a +1. Whew, that was a tough one. I didn't go easy on you guys for that one. All right, let me check the chat. I'll do question M and then I'm going to move on. We're running out of time. We're also probably running out of steam. So I'm going to introduce the next topic and then we'll take a break for the weekend. All right. So question M. First thing I would do personally with question M is I would try to reduce this fraction. So 8/12, you could reduce that. We haven't really talked about reducing.
Can I say the answer?
Yeah, you could say it.
Okay. 2QR over 3P3. Yeah, 3P3.
All right,
Right?
that looks good. It might be right. I don't know because again, I haven't done these.
I don't know. I just did it and that would pop
It's
from me.
right. It's right.
It's right. Woo!
Right.
Yeah. All right, cool. So okay. How did you get that? How did we do it? Well, I'm going to reduce the 8/12. I'm going to divide it by 4. It's going to become 2/3. Your calculators can do this, but I hope you guys can reduce fractions. If not, that's another topic. The p's, what do I do with the p's? Well, the p is going to be -4 minus a -1. The q will be -7 minus a -8. And the r will be -1 minus a -2. So I end up getting 2/3. Now the p, -4 plus 1 is a -3. Q, -7 plus 8 is 1. R, -1 plus 2 is 1, which brings me to this answer. This -3 I move to the bottom. Excellent. Guys, you really are going to want to practice this. I'll be honest, I think we're a little behind in the notes, but I think your level of understanding is, from what I've heard, maybe a little higher than some of the other classes. Now, some of you are brand new and have not seen any of this. Take some time this weekend, do as much as you can. And remember, you can always email me. There is a lot of practice here. And I know like this Faisal, or I think that's your name in the WhatsApp, all of these answers are on D2L. If you go to content and you go to unit 1, you can see all of these answers. So I highly recommend you guys practice. All right. And like there's so many questions here. So there's a little summary here at the end of all of the rules. It looks a bit intense. You might be thinking, oh, wow, how am I going to memorize all of this? Some of these rules really, it's different than memorizing terms in a course. A lot of these rules are common or make sense, right? They're common. I don't want to say common knowledge, but like they're rules that you guys have shown me that you understand. So you don't have to memorize this. Just make sure you know how to use the rules. So it's 3:24. The class ends at 3:40 because of Ramadan. Remember, guys, the bad news is these are 2-hour classes and Ramadan cuts it to 1.5 hours. So if you guys feel this is long, it's actually pretty short. So I just want to take a few minutes to introduce the next topic. I'll probably do a couple of examples and then that's it. I mean, yeah, this is good, actually. I feel really good about where we are. I'm just going to introduce this. I'll show you a couple of examples to get you guys kind of warmed up for this topic. And then on Sunday, we'll really sink our teeth into topics 5 and 6. If you're not familiar with that expression, I just mean we'll really cover or look deep into these types of questions. Topics 5 and 6 are can be a little challenging because it's straight up algebra. Okay, so take a breather. I'm just going to introduce topic 5. Give me 10 minutes or less and you're out of here. Okay, so now that we've looked at unit conversion, we've looked at some properties of numbers, we've looked at order of operations, and then finally we did a bunch of work with exponents. Now we can really, truly get into algebra. Believe it or not, we haven't really talked about this yet. What I mean is we're going to look at solving equations, solving for x. When you guys see algebra, you should be thinking of solving for an unknown. which is kind of the purpose for introductory math. Whether you're in business or IT or engineering, medical science, there's going to be an unknown you're going to solve for. It could be, interest on a loan if you were a business student. In engineering, it might be the flow rate of a liquid. In medical science, it could be the milligrams of medication that you have to solve for. So as much as people may not enjoy this, you will be using algebra in most of your courses that involve any calculations. So just the introduction today, a couple minutes and we'll be done. There's something really important about algebraic expressions, and it's the concept of like terms and unlike terms. And there's a few things I need to unravel here. First of all, what is a term? A term is anything in a algebraic expression. So what I mean by algebraic expression is a group of numbers and letters. An expression, it's different than an equation. There's no equal sign, but it's just a group of numbers and letters. Okay, the numbers we call coefficients, the letters we call variables, and the terms are separated by plus or minus. So in this example, there are three terms. This is what we would call a polynomial. More specifically, it's a quadratic, which we'll get into later. Three terms. 3x squared is a term. It includes a coefficient, the 3. It includes a variable, the x, and it includes an exponent, 2. 4x is a separate term. It includes a coefficient and a variable. 6 is a term. That's the third term. And there is only a number here. And you'll notice I'm not saying coefficient. We call this a constant, but we'll talk about that another day. Maybe in a science course, you'll learn more about that. But I have three terms. So the key thing, and I know we're probably feeling a bit burnt out after all those exponents, but this is a pretty simple part. The key thing to take away from the next 5 minutes is understanding or identifying terms that are like and terms that are unlike. Like terms have the exact same variables and exponents. The numbers don't matter. Coefficients do not matter. It's terms. We're looking at the exponents and variables. 3x and 6x are like terms. Remember what I said a few classes ago? And if you weren't here, I'll just say it again. X is just a representation of a thing. X could be anything. X could be Land Cruisers. X could be apples in your refrigerator. X could be toes on your feet. I mean, it doesn't matter. So when I say 3x and 6x, I'm saying like 3 apples and 6 apples. The numbers don't matter. The terms are comparable. Now, if I said 3x and 6y, that's like saying 3 apples and 6 oranges. They're not comparable. They're not the same thing. Now, look at the next example. 6c squared and 19c squared. The 6 and 19 are irrelevant. They're just kind of the amount. But they are like terms because they both contain c squared. 2xy cubed and negative xy cubed, like terms. They have xy cubed. They need to have exactly the same variables. This one, km squared x5, 7km squared x5. They have a k, they have 2 m's, they have 5 x's, everything's good. Unlike terms will have different variables or different exponents. So 4x and 5x squared, not like terms. 4x and 4x squared, not like terms. Yeah, they both have 4, but the x and x squared cannot be compared. So what's the point? Oh, and this is actually really important, this little note down here. So the number in front we call the coefficient. Okay, you can really see the breakdown here. Coefficient, variable, coefficient, exponent, variable. All right, we're getting there. I'm basically, guys, I'm going to show you these examples and I'm done. Whew. Can't wait. I can't wait for the weekend. Okay. Oh, actually, there's 5 examples here, or 6 examples. I'll show you at least just a couple of them. And I'll review this on Sunday if anybody's lost. The reason we look at like terms is that like terms can be added or subtracted. So for example, 7x plus 7y, there's nothing I can do. 7 apples plus 7 oranges, that's it. That is as simple as it can be. But if I had 7x plus 5x, again, think of it like apples. You have 7 x's and 5 x's, 7 apples and 5 apples. This is like something your teacher would have asked you when you were very young. If you have 7 apples and someone gives you 5, how many do you have? You have 12. The only thing that makes this challenging is instead of apples, we're just calling it x. So I cannot do anything with the x and y, but I can simplify the x's. All right. We'll look more into this on Sunday, but let's look at a couple of these examples here, and then I'm finished. 3 minutes and you guys are out of here. So number 1, 3x and 5x. These are definitely like terms. I just add together these numbers. Now I don't mess with the x, right? This is like saying 3 Land Cruisers plus 5 Land Cruisers. I would have 8 of them. So I add the coefficients. If this was a subtract sign, like you'll see in number 4, 7x cubed y, 5x cubed y, these are like terms. 7 minus 5 is 2. So the answer would be 2x cubed y. Number 2, again, same thing, right? 7 plus 5, I have 12x squared. This is a 1x. If you just ever see a variable by itself, like like an x or a y, or even a y squared, if you don't see anything in front of it, it's a 1. So this would be 10. Pretty easy. Now, of course, 5 and 6 get a little bit more challenging. Before I do, I'm 2 minutes away from being done. Any questions on this before I do the hard ones? Any questions?
No, mister.
All right, cool. You guys are probably tired. I'm tired. I mean, I'm almost done. And for
No, I think this unit is gonna be easier than the other one.
yeah, I think so too.
Easy.
Yeah. Okay. Good. I'm almost done. I'm just going to introduce this, but for anybody who doesn't feel that way, or the new students who are like, oh man, what's happening? We'll take our time on Sunday and look more into this. I will say 5 is a little challenging because of this negative. This negative needs to be distributed into these terms. I'm subtracting this whole bracket. This is called the distributive property. You can see this in class number 1. We'll practice a lot of this on Sunday, but when I distribute that negative out, it becomes 7x plus 5x squared y. But then it's subtract 2x, subtract 3x squared y. Now, look really closely at the colors. The x's, I'm going to combine, and I'm circling them in red. And the green, the x squared y, I'm circling them in green. We will combine those terms. So I get 7x minus 2x, that's just 5x. And then with the green, the 5x squared y minus 3x squared y, 5 minus 3 is 2. This is pretty straightforward. And I was really happy to hear you guys say that. Okay, finale, then I'm done. I will go over this again on Sunday. First things first, combine your like terms in number 6. So find the numbers that have something in common. So I have x squared. There's no more x squareds in this question, so that's done. Let's pick another color. Let's go with blue. I have ax squared. Do I see any more of those? Yep, right here. Ax squared. Pick another color. I'll pick green. Y squared. Nope, I don't have any more y squareds. So the only thing I really need to do in this question is I need to combine these terms and combine my numbers, and that's it. So -7 ax squared minus 2ax squared, you get a -9. You can do this on your calculator, but you can only put in the numbers. You can't put in the x's and the y's and stuff like that, but you can put in on your calculator -7 minus 2. That's where the -9 comes from. And then of course 9 minus 1 is 8. Easy, easy, easy. All right, I'm done. I think you guys are done. Guys, have a really good weekend. If you have any questions, send me an email. I can meet you on Zoom depending on the time. Be safe, wash your hands, wear a mask, have a great day and a great weekend. And if there's any questions, let me know.